and you are able to solve the freckle problem solution. Now the next experiment in the list is the grand dinner. Here you can see the popularity rate C, success rate high, and level 4. I will read the problem statement so we can figure it out how to resolve it and or how to solve it. Each team participating in the year ACM World Finale is expected to attend the grand banquet arrangement for after the award ceremony. To maximize the amount of interaction between the members of different teams, no two members of the same team will be allowed to sit at the same table. So here restriction is that no two members of the same team will be allowed to sit in the same table. Given the number of members on each team, including contestant, coaches, reserved and guests, and the seating capacity of each table. So what we are having as an input, the number of members in each team and the capacity of each table. Determine whether it is possible for the team to sit as described. If such arrangement is possible, output 1 such seating arrangement. If there are multiple possible arrangement and one is accepted. So we need to find out whether this kind of arrangement is possible within the available number of teams and the available number of tables. The restriction is that no two members of the same team will be allowed to sit at the same table. So all the team members should be occupied on different tables. Let us go through our sample input. The input file contains multiple test cases. The first line of each test cases containing two integers. One is m and the another is n. So m is 70 will lie in between 1 to 70 and n will lie in between 1 to 50, denoting the number of teams. So m will indicate the number of teams and tables and n will indicate the number of table. The second line of each test cases contain m integer, that is the number of team, where the ith integer mi indicating the number of members of team I. So the second line, that means this line, you can see here. What does 4 indicates? 4 indicates m. M is nothing but number of team members and 5 indicates the number of table. Okay? And the second line will indicates the total number of members in each team. There are at most 100 members of an team. So there could be 100 members in a team. The third line contains n with the jth integer nj 2 to 100 indicating the seating capacity of the tables. The test case containing 20 m and n terminates the input. Okay. So here you can see the sample input 4 and 5. So 4 indicates what? Number of teams. There are 4 teams. N indicates number of tables. I have an image where I have mentioned the team numbers and table so that you will get a rough idea. Next we will discuss about the output. Output for each test cases, print a line containing either 1 or 0 denoting whether there exists a valid seating arrangement of the team members. So you need to display 1 or 0 if there is a valid seating arrangement. Valid seating arrangement means 1. No two members of the same team will be allowed to sit in a same table. And in case of successive arrangement, print m additional line where the ith line contain a table number from 1 to n for each of the members of the team. So you need to print all the table numbers of each of the members in the team. So I had detailedly sketched the input and output because it is very important that you should understand the sample input and sample output. Accordingly, you will figure out to write the code. So I had detailedly mentioned as, suppose this is our sample input. So what does this 4 indicates? This 4 indicates is 4 is nothing but M. Number of team. 4 is what? Total number of teams. And 5 is what? Number of tables. Okay? So 4 is number of team and 5 is number of tables. And the second line will indicates what? M integer number of members in each team. So there are 4 team. Okay? And this is team 1, which consisting of 4 member. This is team 2, which consisting of 5 member. This is team 3, which consisting of 3 members, and this is team 4, which consisting of 5 members. So second line in an input statement, it is the total number of members present in each team. And the third line in your input statement is nothing but n integers seating capacity of the table. So table 1 have the seating capacity as 3, table 2 have the seating capacity as 5, table 3 has 2, table 6 has table 4 has 6, and table 5 has 4, and so on. And this is the second sample input. So there are 2 sample inputs. So output for the first is been what it is expected that if there is a possibility, if this kind of arrangement that no 2 members of the same team will be allowed to sit in a same table. That means every members of this team should occupy seat on different table. So if it is possible, then you need to return, the output should return 1. And what the output should return? The seating arrangement of each and every members in a team. Say, for example, you can say the first team is of 4 members. This is team 1, which is of 4 members. So 4 of the members, these are what, where the seats is been given to these 4 peoples. So on table 1 member, on table 2 another, and on table 4 another, and on table 5 another. So 1 to 4 indicates what? The table number. So what you are going to return? You are going to return the table number, the arrangement in which this 4 member will get occupied. Similarly, for the team 2, there are 5 members. So the arrangement is likewise is 1, 2, 3, 4 and 5. The third team consisting of capacity of 3 members, and therefore it will return the table number as 2, 4 and 5. And the last one team consisting of capacity of 5 members, so the table numbers are 1, 2, 3, 4 and 5. Here you can see the output that neither any of the team members is being occupied in the same table with the same table number. So it is this kind of arrangement is possible in this scenario. And the second sample input returns 0 because this kind of arrangement is not possible in the second sample input. So how you are going to solve, or how you are going to write a program for this? You are going to solve this problem with the help of greedy approach. First, you need to have a structure or a class for a table to sort the table number. That means you need to find out the valid table solution in which you are going to sort the table number. Second of all, you need to maintain 2 array. One to maintain the number of members in the team, and the another to maintain the total number of tables. Now you need to sort the table in a descending order according to its capacity. And for each member of every team, greedily choose the table with maximum capacity and assign it to that member, and then reduce the capacity by 1. The thing you need to go through is that to check whether the maximum team size is greater than number of table, then you can say that no such solution is possible and there is no need to perform the further calculation. Directly you can return the 0 and you can terminate the program. So I hope this is helpful for you, and try to solve